Hi, everyone. Thank you so much for joining us today for our event on creating mobile apps with Flutter and Firebase. My name is Lauren, and I'm the content manager for the Google Cloud community. Joining us today are Shivank and Utkarsh, who will be leading the session, content, and answering your questions today. Questions are encouraged, so please feel free to add those into the YouTube chat box, and we'll be sure to get to them either in the chat or at the end of the presentation. We also have a few pre-submitted questions that we will cover as well. For any questions that we don't get to, please share them in the Google Cloud community, and someone from the community or the Google Cloud team will be happy to help you out. And there's a link to that in the YouTube description, as well as a blog series that lives on the community specific to creating mobile apps with Flutter and Firebase. So feel free to check out those resources on your own time. Thank you all for joining us. If you want, please share where you're joining us from in the chat. I see we have some folks from Montreal. I'm from Los Angeles, and we're excited to present this content for you today. With that, I'll hand it over to the team to take us through the content.
Thank you so much, Lauren, for this lovely introduction, and welcome to this. So, before beginning the session, first of all, let me start by introducing ourselves. So, first, I'll pass it on to my teammate Shivank, and then I'll.
Thanks, Utkarsh. Hello, everyone. This is Shivang Avasti. I'm part of the Google Cloud India team. I'm a strategic cloud engineer based out of the Gurgaon location. I've been working in the Flutter and Firebase domain for quite some time now, and myself and Utkarsh, we have been working on a couple of engagements on Flutter and Firebase, and we have recently co-authored a book on Flutter and Firebase. So feel free to check it out. It is available on Amazon, and we are so happy and to be here in this session with you all, and we can get started. Yep.
Awesome. Thank you so much, Shivang, for introducing yourself. So, as you guys can see on the screen, my name is Utkarsh, and I'm working as a cloud migration consultant in Google Cloud. I'm based out of New Delhi, India, and I've been working in Google for the past 18 months. And in the past 18 months, I've worked on a number of engagements, which includes Flutter and Firebase as well. And as Shivank mentioned, we have also co-authored a book on Flutter and Firebase, which is available both on Amazon and on Google Play Store as well, Playbook as well. Apart from this, we have also co-authored a learning series on Flutter and Firebase as well, which is also available on Google Cloud Community. So please feel free to take a look. We do have the links to that particular series later in the deck. So without wasting further time, let me quickly dig into the agenda for today. So first of all, we'll discuss what was life before Flutter. Then we'll discuss about Flutter and Dart. Then we'll be discussing about Firebase, because Flutter and Firebase are basically, you can say, a match made in heaven, wherein Flutter takes care of your front end and Firebase takes care of your back end. And then we'll have the Q&A. Basically, we'll answer the pre-submitted questions, and once they are done, we'll also try to get to the live Q&As as well. And there are also two demos. One is related to Flutter and other is related to Firebase. So we have sort of divided the demo. So once we complete the Flutter part, we'll have the first demo, and once we complete the Firebase part, we'll have the second demo. So let's dig into the details. Cool. So let me give you a quick background what life was before Flutter and Firebase actually existed. So native apps are software applications used in platform where programming language of the app is based on platform and designed specifically for that platform operating system. So whatever hardware and software that the operating system uses will be used by the native apps as well. So basically there were some shortcomings and some disadvantages of using this particular functionality, which included cost, development complexity, time, and the development process was time consuming. It required frequent maintaining updates. So let us sort of dig deeper into these disadvantages. So let's start with the first disadvantage, which is the cost. So the development and maintenance cost of a native app is considerably high, given there should be separate versions of the same application depending on the platform or operating system. So so if you are hosting and developing an app, you'll have to develop it separately for iOS, for Android, and web. So in that particular case, you'll have to pay the cost of the infrastructure, the developers, and the cost of maintaining those apps three times. So Flutter tackles all these challenges, which we'll be discussing later on. Then there's the development complexity. Developing and maintaining native app is complex since different developers are needed for each platform, that is Android and iOS developers. So this is self-explanatory. Before Flutter came, we actually had to hire separate developers for Android, for iOS, for web, which actually increase the cost. And also it resulted in a lot of development complexity as well. So, because if imagine a scenario when let's say a team of 10 people are working on a project and two of them are leaving the organization, then that sort of creates a situation of dilemma where those 10 then the new people need to be hired, and then those two new people have to get upskilled, have to be given code walkthroughs and everything. So it basically increased the go to market time as well, plus a development complexity as well. Third is the time consuming. Since native apps are developed for multiple platforms, it requires more time to write code for specific operating systems and to make the look and feel consistent across platforms. So, I mean, you guys might be aware that for Android and iOS, the look and feel of the app sometimes are different for the same app that we are using. So it required a lot of complexity, plus it consumed a lot of time of the developers to give the similar UI feel for the app across different platforms. So that sort of increase the complexity, the cost, and increase the go-to-market time as well, which can ultimately result in some cases losses for the company as well. Then comes the most important part, which is maintaining updates. So creating an application and hosting it and on the Play Store or the App Store is one thing, but maintaining the app is an altogether a different ball game, because you constantly have to come up with new features, plus you need to fix a lot of bugs or glitches as well. So doing all these things separately for three different platforms created a big fuzz for the companies, which is why a solution was needed for all these problems. Now comes Flutter and Dart into the picture, and let's see how Flutter and Dart solve the problem. So before beginning, let me quickly give you an overview of Flutter's frameworks, abstract, how it is hosted on your hardware and everything. So Flutter is an open source project hosted on GitHub, which with contributions from Google and the community. Flutter uses Dart, a modern object-oriented language that compiles to native ARM code and production-ready JavaScript code. So here you can see in the diagram that on your hardware you need to have a platform specific embedder. Then in the Flutter engine, it is basically a C++ engine, plus it has Dart feed it into its core. Then on top of that, there is the Flutter framework, which we develop through a programming language called Dart, which is very similar to JavaScript. And inside Flutter, you can see there are things like widgets, gestures, etc. And there's also a very famous saying that in Flutter, everything is a widget. So once you actually start developing your apps, you'll get to know that every data that is there in a Flutter application is basically a widget. So you create different types of widgets. It can be scaffold, it can be your stateless, your stateful widgets, which actually contain the information which will be displayed on the screen. Then on top of it comes your code. So now let's quickly discuss what are the advantages of Flutter. So same UI and business logic in all platforms. We know that essentially any cross-platform framework provides a way to share the code base between the target platforms, but there are no such application frameworks that allow sharing of both the UI code and the UI itself besides Flutter. So the problem that I mentioned earlier, that for creating an application in three different platforms, Android, iOS, and web, you need to have three different sort of developer teams, different skill sets. You had to maintain different infrastructure, which was costly, time consuming, and complex as well. But with Flutter, you just need to maintain a single code base, and with the help of that one particular code base, you'll be able to deploy apps in Android, in iOS, and on the web as well. So on the bottom of the screen, you can also see a slide diagram of how Flutter works. Now let's discuss the second main advantage of Flutter, which is reduced code development time. The Flutter development framework functions quicker than its alternatives. In most cases, you can expect a Flutter app to require at least 2x fewer work hours compared to the same app developed separately for Android and iOS. The main reason is simply you don't have to write any platform specific code to achieve the desired visuals in your application. Any 2D based UI can be implemented in Flutter without interacting with native application counterpart. So I mean, as I mentioned earlier, because you're only maintaining one single code base, that significantly improves your development time, plus your go to market time. Plus Flutter also has a very cool feature, which is a Flutter hot reload, which basically helps the developers in testing their new features, or if they have fixed a bug in real time, so they don't have to restart the application, go through the build pipeline and everything again. Flutter does all the magic in the background all by itself to help you out on this. Also, I mean, when you are natively developing an application, you need to write codes in Kotlin, Java, then C sharp, everything. But in Flutter, you just need to write code in your Dart programming language. Plus Flutter also provides a lot of cool animations as well, which you can simply include in your pubsec.yaml file, and you'll be good to go. So now let's quickly discuss about the widgets. So as I mentioned earlier, in Flutter, there's a very famous saying that everything is a widget. So widgets are user interface components used to create the user interface of the application. The central idea is that you build your UI out of your widgets. Widgets describe what the app user's view should be given their current configuration and state. The state of a widget can be maintained whenever necessary using a stateful widget. So here on the right hand side, you can see a quick flow chart of how widgets function. So you can see platform specific widgets, then you can see rendering, animations, gestures, foundations. Then there's the C++ engine, which we discussed earlier when we were sort of discussing the schema of Flutter. And then there's the platform specific embedder, and below that there's the there's your hardware and all. So inside Flutter, everything is a widget. You build your entire UI out of your widgets. And in Flutter, there are mainly two types of widgets. First is a stateless widget, and second is a stateful widget. So these widgets are sort of self-explanatory. So if you're hosting some sort of a static content which is not bound to be changed, let's say you are creating the homepage of your screen, and you have the name of your application, so you can host it in a stateless widget, because the information is not bound to change. The name of the application will still remain the same. But if you let's say if you are hosting, or if you are building a weather application which will constantly be checking the weather from your background database with the help of APIs, then you need to build then you need to use stateful widgets, because the weather, the temperature, the air pressure, and all these minute details will be constantly changing. So you need to keep your application up to date. So this is how the background architecture of stateless widget versus stateful widget looks like. Basically, in stateless widget, it's nothing, just a widget, and in stateful widget, it's a widget plus it maintains its state as well, as I mentioned earlier. And here you can see how different calls or different events in the application itself, when you'll be programming it, impacts your stateful widget, because the data inside the stateful widgets and everything will also depend on what button is pressed by the user, what information is changing in the background. So a lot of these things also depend on your architecture and everything. Then let's quickly discuss about Dart. As I mentioned earlier, Dart is a client optimized language for developing fast apps on any platform. Its goal is to offer the most productive programming language for multi-platform development paired with flexible execution runtime for app frameworks. The following code shows you a simple Dart program. So as I mentioned earlier, it follows the syntax of normal JavaScript. So you can see the normal syntax here. Plus, you can see on the right hand side some of the features that Dart has, like it's open source, platform independent, it's object oriented, it's concurrency, extensive libraries, it's easy to learn, flexible compilation, it's type safe, it's object oriented. Again, it provides browser support. Plus, it has a hugely backed community as well. And on on Flutter's basically on Flutter's official documentation page, you can see a lot of cool packages, plugins also getting updated on a daily basis, or on a weekly basis, wherein you can see a lot of cool features which you can use in your applications as well. And those plugins and those packages are both from the community and from the Flutter team itself. So here's a quick overview of Dart language, supporting the different data types which we generally have in a programming language, like numbers, strings, booleans, lists, and maps. I don't want to get into much more detail in this because I already knew that most of you are aware about it. So here's an example of, let's say if you're writing some sort of a list. So here's the syntax for that. If you're using a map, here's a sort of a syntax for that. And there's also a dynamic example. So if the variable type is not defined, the defined type is basically dynamic. So all these features are constituted inside the Dart programming language. Now, as I mentioned earlier, there'll be a quick Flutter related demo. And after that, I'll be passing on the baton to Shivank, and he'll be speaking about Firebase. So I'll quickly play the demo now. So we have actually recorded both of the demos just to be sure, because sometimes it happens that on the day of the event the application is malfunctioning or anything can happen. So in order to avoid such scenarios, we have basically recorded all the demos. So I'm going to play the demo here now. Do let me know in the chat if you are somehow not able to hear the sound. Awesome. So let's start with the first part of the demo. So just for everyone's reference, in this particular stream or in this particular live event, we'll be showing you two demos. The first part of the demo will be focusing on Flutter, and the second part of the demo will be focusing on Flutter and Firebase, wherein basically you can understand how can you base your apps backend on Firebase. So let's continue with this part of the demo, where I'll first of all show you how our app looks like as of now. So let me run the app in the debug mode. So it's launching. Bear with me for a minute. It should be up and running now. So in the meantime, let me explain to you what we are basically targeting here. In this particular demo, I just want to show you how Flutter's hot reload feature actually works. And I think it's a very cool feature because it has four main advantages. One would be that it provides rapid iteration. So hot reload feature allows developers to make changes to their code and see the results almost instantly without the need to restart the entire app. Second, that it helps in improve productivity. Third, that it provides an enhanced user experience. So, with the help of hot reload, it enables developers to fine tune the UI and user experience in real time. Fourthly, it helps in efficiently debugging. So, all these features are play a key role to user experience as well as a developer experience. So, as of now, you can see on the screen that the app is a very vanilla app, wherein this is the sign in page, and we'll also be using this app for our for our second part of the demo as well. So now let me make some changes to the app in real time, and I'll show you how the changes come into effect. Cool. So as we are making changes to the login screen, so I'll be making changes in this auth underscore gate dart file. So I do have the code in handy with me. So let me just make the changes very quickly. And there's also a text about welcome to Flutterfire. Please click on sign in. Let me change it to welcome to Google Cloud Community. And let me just quickly hit save. And you I think it just came up for a blink of a second, but you could see the hot restart was in effect. And now let me quickly open the app, and voila, you can see now our home screen has changed. You can see this image that I have added to our home screen, and so it's an image of Flutter and Firebase. And I've also changed the text to welcome to Google Cloud Community. Please sign in. And the login functionality, which was before in the center of the screen, has now actually moved to the side of the screen, and the user experience is now a bit better. And you can see I actually didn't restart the app, or I didn't do anything. I just updated the code, hit save it, then fluttered it, did its magic in the background. Hot reload came into effect, and the UI of the app changed in real time. So this is how Flutter's hot reload feature works. Awesome. Thank you so much. I hope you guys like the video. So, and it's also my first time, so please bear with me if you felt that it's it was okayish. But since it was my first time, please give me the benefit of the doubt. Now I'll pass on the baton to my teammate Shivank, and he'll be taking care of the rest of the presentation. Over to you, Shivank.
Thanks, Utkarsh. Thanks for the wonderful presentation, and it was surely a enlightening and learning experience talking about Flutter with you. So, thanks for that wonderful presentation. Now, let's quickly jump on to the Firebase section here. So, as most of us here might know, Firebase is basically an app development platform that is currently helping millions of businesses and folks around the world, and it is helping people build and grow apps that users love, and it is being backed by the Google. So there are in this particular slide, and in general, we are going to talk about some of the features that Firebase currently has in place, and what are those actually. So with Firebase, you can build powerful apps at scale, which basically ensures that Firebase enables developers to spin up their backend without managing servers. So, if you are a new developer, or if you are someone who is only concerned about the functionality of your code of your application and does not want to get into the hassle of setting up a server and maintaining the entire infrastructure, then Firebase is definitely a choice for you. Firebase basically helps you scale effortlessly to support millions of users with Firebase, and it includes the different functionalities that you would need for your application. So, be it databases, be it the ML infrastructure, be it hosting, storage, or anything else that you want, would be being backed by the Firebase here. Second thing is the simplification of operations. So Firebase definitely improves the app quality in less time with less effort, and this actually helps in simplifying the testing, triaging, and troubleshooting, which are very crucial for running an app at the production level. The user engagements also gets improved a lot if you are using Firebase. So with all the best features in market that Firebase currently offers, which are like rich analytics, A/B testing, messaging campaigns. Firebase basically understands what are the quick insights about your application, and that helps your users to better support, and that helps your application to better support the users and to retain them. And there are experiments also being run within the Firebase to test the ideas and uncover new insights about your application. So these insights are continuing to be improving with every day, with every second, and that's how Firebase ensures that we are at the scale. Next slide, please. Cool. So now that we have a brief overview about Firebase, let's talk about different features of Firebase in a little more detail. So as my colleague Utkarsh has mentioned earlier, Flutter and Firebase are basically a match made in heaven. So they complement each other well. Flutter takes care of the front end aspect, and Firebase takes care of the back end aspect. So in here we are going to talk about the real-time database that are available within Firebase. So Firebase provides a real-time NoSQL database that allows you to synchronize data across multiple clients in real time. In the current scenario where of not having a centralized database is the best idea and the best thing that you could do to your application. So Firebase follows that methodology, Firebase follows that ideology, and this is very useful for building collaborative application or apps that require live updates. So this is one of the cool features that Firebase offers, that is the real-time database. Next slide. Thank you. So authentication in any application that you are going to develop, or you have developed, or you will be developing in the future, authentication is a very crucial and the critical component. The reason being, authentication is something that would define which particular user you are, and if you are able authorized to particularly log in into this particular application or not. So to support that use case, Firebase offers built-in authentication services, which includes all the industry standard options like the email password authentication, your social logins, be it through Google, Facebook, Twitter, etc. Everything is being covered under the Firebase authentication, and it simplifies the process of adding user authentication to your Flutter app, and basically providing you a secure and a very reliable authentication solution, so that you only focus on the code of your application, and rest all will be taken care of by the Firebase server itself. Next slide. Cool. Now that we have covered the database and the authentication part, let's now quickly jump to the two amazing features provided by Firebase, that is Cloud Firestore and Cloud Functions. So Cloud Firestore is basically a scalable and a flexible cloud database offered by Firebase, which allows you to make and to store and query structured data. So if you are having a structured data for your application, and you require a very robust and reliable system that can store and query that data, Cloud Firestore should definitely be your choice. And Firestore, some of the cool features that Firestore has is providing the real-time updates, providing offline support, and the seamless integration with other Firebase services. Uh, that is one. Now jumping quickly to Cloud Functions. So Cloud Functions, just like the Cloud Functions that are there in GCP, Firebase Cloud Functions also allow you to run server-side code in response to events which are triggered by the Firebase services or HTTP requests. So in case you are having an application which is having a use case, and most of the applications have such use cases, where if there is a request, if there is an event that is happening, and you want certain action to be triggered on the basis of that event, then Firebase Cloud Function is a choice for you. And with such functionality available within Firebase Cloud Function, it enables the user and the customer and you to basically offload the task to server, and to perform complex operations such as image processing and sending notifications seamlessly through Cloud Functions. Okay. Now let's come to the cloud storage aspect here. So we talked about Cloud Firestore there, where if you are having a structured data, but what if you are having a content that is being generated on the fly, or a content that your user is uploading, and it might not be a structured data, it could be a file or an image or a video. So Firebase storage comes to your rescue there, and Firebase storage provides a very simple and a secure way to store and serve the user generated content. So if your use case is having something like the support, and it requires the support for images, videos, or documents, or any other files, then Firebase storage is the go-to solution for you. It seamlessly integrates with other Firebase services and offers the very powerful features that are like file metadata, security rules, and URL-based access. The other cool feature that Firebase currently offers is analytics and crash reporting. So, as we all know, within the app development domain, how critical it is to identify the crash that has happened on a particular device, and how critical it is to identify the root cause of it, and how critical it is to identify the analytics of your application. So Firebase has a very robust mechanism in the background to ensure that you have a very strong analytics tool that basically allow you to starting from the tracking of user engagement to monitor the app performance to gain insights into user behavior. So from Firebase, in a single pane of dashboard, you will be able to see how your application is doing on a granular basis, as granular as you want and as broader as you want. All right. So with that, let's jump on to Firebase Cloud Messaging. So Firebase Cloud Messaging enables you to send notification and messages to users across various platforms, including iOS, Android, and the web. So in case your application requires within app messaging sort of a functionality where two users or two use cases need to interact through messages within the application, then cloud messaging is the go-to service for you. In If you're using cloud messaging, you can engage with users in real time, and you can keep them informed about the important updates or events of your application. Next slide. So now let's come to the DevOps aspect of this presentation. So as we all know that for distributing an application or for developing an application, and if you are willing to make the changes, and there's a whole cycle that goes in the background for software development, and thankfully Firebase has that app distribution and the linkage with GitLab, which is a highly customizable CI tool. So the CI/CD pipelines that are available within GitLab are configured using a YAML file, as we all know. And there are different stages in the pipeline, but the two most important stages for a Firebase project are the build and test deploy stages. So this diagram here shows a typical representation of how the code would work if you are using Firebase there. So the way it works is that first of all, you would be using GitLab as the version control, and you would be pushing your code through GitLab, which would be generating an image through Docker. And first it would be pulling it, and then it would be building that image. Then your unit test would be executed to ensure that any errors or any logical errors could be identified there at the unit testing stage. And then these after if this test runs out perfectly, then this would be passed on to Firebase deployment tool. From there you can directly have an option to directly distribute the app through Firebase, and you can check the Firebase console. So this is how from the code level to the distribution, everything will be taken care of within a single pipeline here. So now comes the demo time, and we'll quickly jump on to the Firebase demo here, where we'll be showing the representation of how a Firebase app works.
Awesome. Awesome. So this is the Firebase console. And now on your screen, you can see the first thing that you'll see when you'll open the Firebase console, which is basically a list of all the projects that are available. Plus, if there are any projects that are already that you've already created, you can see it over here. And then there's a button to add a new Firebase project. For the sake of this demo, we'll be using the project that I've already created, called as Flutterfire UI Code Lab. But I mean, let me also show you how you can create a project of your own in just 2 quick steps. So let's click on the Add Project button, give your project a name, let's say test in this case, click on Continue. Then it'll ask you that you want to enable Google Analytics for your Firebase project. For the sake of this demo, we do not need A/B testing or user segmentation or targeting across Firebase products. So we'll disable this. But just in case, once you're more familiar with Firebase and Flutter, then you can, if you want to play around with the settings, you can enable Firebase Google Analytics for your Firebase project and play along. So Once you've made your choice, you can click on create project, and the project will be created. So let's hop over to the previous screen. Okay, so once your project is created, you can open that particular project and you'll see this overview where you'll basically be able to see all the different Firebase applications that are available. As we already discussed, that Firebase is a suite of applications wherein it has different applications like the Firestore, authentication, storage, etc., etc. So it's taking some time to load. Let me try to refresh the page and see if it does the job. Awesome. Yeah. So since we are trying to create a user and see if the user is now able to log into this to the app, let's click on authentication. Once you'll click on authentication, you'll see this particular window where you'll see the users tab, the sign in method, templates, usage settings. So since we want to add another user, we'll click on add user, and here basically you can see you can enter the email address and password. For the sake of this demo, I'm using a fake email address, but you can also use a real email address. The only downside of using a fake email address is that you will not be able to verify or send a verification email to the fake email address. So now let's just quickly click on add user. And in the meantime, just in case if you're wondering if you want to add multiple users at the same time, then that is also possible with the help of Firebase SDK. So with the help of Firebase SDK, you will be able to bulk upload and create uh, n number of users at the same time. Awesome. Now let's try to log in with the user that we created via the Firebase console. Let me quickly enter the credential. It was user1@email.com. First password was user123. Let me click on sign in. And voila, we were able to log in to the user via you were basically able to log into the app via the user that we created. And this is the welcome screen. This is the little image of a fish that I actually added. And here's my profile button as well, where you can see I have already added a name, but you can also go ahead and always, edit this name as well. So once I click on this button, you'll be able to see that I was able to edit the name. So as I mentioned earlier, or I may not have, but the only downside of using a fake email address is that you'll not be able to send a verification email to that fake email address. And on just below that, you can see as of now, we have only enabled email sign in to this particular app. But now we'll go a step further and we'll also enable Google authentication along with the email sign-in method. So let me quickly hop on to the Firebase console and I'll show you how it can be done. So first of all, let me sign out from here. So as you guys were able to see on the previous screen that we were able to log in via the user that we created. Now, just to enable Google authentication, we need to move on to the sign-in method tab. And here you can see for this particular project, it is already enabled, but just in case if you want to enable it for your own project, you just need to click on add new provider, select Google here, and then it will ask you some details. You just need to fill them and Google authentication will be enabled for your particular project as well. Now, the second, now to enable Google authentication for your application, let me quickly make some changes in the code, and I'll show you uh, how we can enable Google authentication. Awesome. So for this part of the demo, in order to enable Google authentication in the app itself, I do have the code in handy with me. So basically, you need to make a bunch of changes in the auth underscore gate dot dart file. So let me quickly change the code. Oh, there are some errors. Let me quickly just address it. So it's saying Google provide configuration. I require client ID. Hopefully this should do the job. And you can also find this client ID on the Firebase console itself. Awesome. So let me move to the main.dart file and run the application in the debug mode. And if I guess you were also able to quickly see the hot restart feature as well. Basically, when I ran it in the debug mode, it did a it did a hot reload. And let I'm just quickly waiting for the app to launch. And awesome, it has launched, and now you can see sign in with Google button as well on the screen. And once you click on this button, sorry, it took a bit of time. Basically, once you click on the button, you already know the drill. You need to enter your email address, click on next, follow the usual steps that we have, and you will be able to set up Google authentication with your app as well. So thank you so much, everyone, for joining. I'll cut over to the main presentation now. Thank you.
Awesome. All right, great demo. So I think we are able to get a good grasp on how the Firebase console looks like and what are the different features that Firebase console supports. With that, let's jump on back to our deck. So perfect.
Awesome. Yeah, thank you so much for that presentation, those demos. Thank you everyone for joining us and for your questions. Before we dive into your questions, we did just have a few resources to share with you. So the first is the mobile app development series that we mentioned earlier in this session. So feel free to use that QR code, or we'll drop the link into the chat where you can check that out. And there's a series of articles and accompanying videos that will show you step by step how to do different tasks or programs with Flutter and Firebase. So definitely recommend checking that out on your own time. And then we also have a couple links here on the right related to the Google Cloud community. So if you're not a part of the community, we highly recommend you join. This is where you can ask questions, engage with your peers and Googlers in forums, as well as stay up to date on events like this. So we have a couple of events coming up tomorrow and next week that you can see listed here, and you can see all of them at that third link there. And then lastly, we'd love to hear from you. It'll take 30 seconds or a minute just to submit our feedback form. So if you want to share what you liked about this event, what you'd like to see that's different or new, and ideas or topics for future sessions, we'd love to hear from you in that form. So with that, we'll start diving into your questions. So thank you everyone for the questions that you submitted so far. We'll be sure to get to them, keep them coming, and yeah, let's dive right in. So if you want to go to the next slide, we have some pre-submitted questions, which may also address some that you are thinking of or that are in the chat as well. So we'll start with the first one here is, how do you host backends for your app on Firebase? Can it run Python scripts? And how do Cloud Functions work with this setup?
Sure. Thank you for the question, Lauren. I'll take this one, and Shivang, maybe you can take the next one.
Sure, sounds good.
Thank you. So yes, so basically to quote, yes, you can definitely host your backend on Firebase with the help of Python. So Firebase provides a number of services that can be used to build and host backends, including Cloud Functions, which allows you to write codes and run on which run on Firebase servers. without having to worry about managing the infrastructure, which we've already discussed in the deck. Then there's a Cloud Firestore, which is a NoSQL database that can be used to store and sync data between your app and your backend. Then there is Cloud Storage, which is basically a storage service that can be used to store files and images, which is basically means your static data. Then there is Cloud Messaging, a service that allows you to send push notifications to your app. And coming to the second part of the question, to host a backend on Firebase, you will basically need to create a Firebase project, which we sort of discussed in the demo. Then you need to enable these services, which I actually didn't enable. So you need to switch on that particular button. So once you have done this, you can start writing code for your backend. Firebase supports a number of programming languages, which includes Python, Node.js, Java, etc. So yes, you can use Python to write your backend code. Cloud functions are also, a great way to add functionality to your backend without having to worry about infrastructure, because they are cloud functions are basically triggered by events, such as whenever a user is adding an item to the shopping cart, if it's e-commerce application, or when an event triggers. So to use cloud function, you will need to write a function and deploy it to Firebase. Once you have done this, functions will be triggered based on the events. And I basically also have a sort of a code lab practice for you, which you can do to get more understanding about this. I am actually not able to see the okay, cool. So I'll paste it in the private chat, and maybe Lauren, you can share it with the folks here, and
Yep,
they'll be able to benefit a lot from that.
perfect.
Thank you. Okay, I'll quickly move to the next question. So
Awesome.
maybe Shivang, you can take this one. Thank you.
Sure, thanks, Utkarsh. So the question says, can you show an example of using offline storage? What are the offline debugging methods for a production desktop Flutter application? All right, so since this is a two-parted question, I'll go one by one and I'll take the first one first. So for an example of using offline storage, right? So probably let's take the example of a note-taking app. So in a typical note-taking app, there would be users who can create, edit, and delete notes. And by using offline storage, you can save the notes locally on the device. So when the users create or modify the notes while offline, the app stores the changes locally first of all, and this allows the users to access and modify their notes even when they don't have an internet connection. So this functionality is being supported by Firebase, and once the device reconnects for this particular example, so once the device reconnects to the internet, the app can synchronize the changes with the remote server and ensuring that the notes are backed up and accessible across devices. So that could be one example. Other example could be a task manager app that could allow the users to create and manage different tasks. And offline storage can enhance that app's functionality by providing an offline access to tasks where users can view and update their tasks without an internet connection. Similar app could be a newsreader app. So a newsreader app aggregates articles from various sources in a typical newsreader application, and offline storage can improve the user experience by allowing offline access to previously accessed articles. So if somebody wants to access an article that they have already read about and they want to read further, they can probably use that kind of a functionality. So these are the typical use cases where you can basically support and basically offline storage could be utilized there. Second thing is another example that just came in my mind is probably the logs and error reporting. So basically, any such app could also be utilized using the offline storage. Now, coming to the second part, which is the what are the offline debugging methods for production desktop Flutter applications. So this could be done through a series of events and not just one event. So what you can probably do is the very first thing that we can suggest is start with the unit and integration testing. So the user needs to develop a comprehensive suite of tests that cover various offline scenarios. That would be the initial step, and once you have done that, you should start writing unit and integration tests to validate the behavior of your application when there is no network connectivity or when the network is unreliable. Those are the key areas that you should target. And one more thing that we can suggest there is that you should use tools like Flutter Test, which is a package available on pub.dev, and there are other packages also available like Mockito, which can facilitate testing and help you simulate the offline conditions. And I think by incorporating these practices, you can effectively utilize offline storage with Flutter and Firebase while implementing robust offline debugging methods for your production desktop Flutter application. Back to you, Utkarsh.
Thank you so much, Shivang. That was a wonderful explanation, I must say. So,
Awesome.
sorry, you were saying something, Lauren?
Yeah, no, that's great. I'm just going to move on to the next question if we want to cover it.
Sure.
Also, we'll want to make sure that we can flip over to some of the live chat. So maybe we'll take this one and then we can flip over to some of the live Q&A.
Definitely.
Cool. So here, one question is, how can we reduce the APK file size and the development compilation time?
Thank you so much for submitting this question. So, on the top of my head, I can think of three or four methods by which you will be able to achieve this. So, first of them will be code optimization. So, you can remove unused dependencies, packages, and assets from your project. Minimize the use of external libraries and plugins, and only include the ones which are necessary for your app's functionality. And secondly, inside code optimization, you can also optimize your code by efficient algorithms, data structures, and avoiding redundant calculations and optimizing resource usage. Second could be done by asset compression. By asset compression, I mean compressing and optimizing your app's assets, such as images, videos, and audio files, reduce their file size without significant loss in quality. Use tools like Flutter Image Compress or Tiny PNG to compress images during the build process. And for videos, you can also consider using SVG instead of bitmap images where possible. Thirdly, you can also use code splitting. So you can split your app's code into smaller modules or chunks to enable dynamic loading of specific features or screens when needed. And you can use techniques like code splitting and lazy loading to load code and assets on demand, reducing the initial load time and app size. So these are some of the methods that you can use to significantly reduce your app load time plus your APK file size as well. I do have a few other suggestions as well, but I would like to address the questions which are there on the live Q&A as well. So over to you, Lauren.
Awesome. Sounds great. So let's start with some of your questions here is, did you recommend to program Flutter in VS Code or Android Studio, talking about mobile application?
Utkarsh, do you want me to take that?
Yeah, you can take it. Sure, no worries.
Thanks. So, Philip, and I'm sorry if I'm pronouncing your name wrong, so apologies for that in advance. But so to answer your question, it is recommended. Like you could do VS Code, you could program in Flutter using either VS Code or Android Studio. Both are possible, and both of them are actually very good IDEs. But it is recommended to use Android Studio, and there's a very simple reason for that. That we have a better community in Android Studio, which are supporting different plugins that could help your Flutter development and that could ease out. So while learning this and while having this Flutter journey, myself and Utkarsh, we had figured out some of the key issues that VS Code does report when you start developing in Flutter, and that's why on a large scale application and for very complex applications, it might hinder the application performance as well, and also reduce your development time significantly. So it is always advised to use Android Studio because the integration is just seamless, and it helps you a lot. So I hope that answers the question.
Great. Thank you for that.
Thank you.
Kind of a forward-looking question here, but when will Cloud Functions support Dart language?
Okay, so let me take this one. So first of all, it sort of does support Dart. So you can use Dart to write functions that are triggered by events such as HTTP requests or via your cloud pops up messages. To use Dart with your cloud functions, you will need to install Dart SDK and the cloud functions for Dart plugin. Once you have done this, you can start writing your functions. And similarly, as I shared an important resource with you earlier, I'll again share one plugin that you can use to uh, you know write cloud functions in Dart. So it supports Dart 3, and it is a package which was published 5 days ago. And the publisher is verified Firebase Google.com. Thank you so much, Laura.
Great, thank you. Okay, we'll take one more. A little bit of a broad question, but realistically, why hasn't everyone adopted Firebase?
I would love to take that, and that's a good question, Shashank. So that's what we are on. We want people to adopt more and more people to adopt Firebase, and frankly speaking, there are a lot of use cases that Firebase and Flutter could very well work on, and we have a very outgrowing community here, and we have seen a lot of interest from the community for these two services. So recently, we have also been seeing a lot of enterprise customers asking for Flutter and Firebase, and that shows the power of Flutter with just a few years in the market, and we already have a very strong community out there. So uh, hopefully, we should be seeing that very soon.
Thank you so much, Shivang. And I just wanted to add to that for compliance reasons, we cannot reveal the name of the enterprise customers. But trust me, the folks that are actually using Flutter are a very big and giant organizations, and slowly people are adopting Flutter. And to increase the awareness of Flutter and Firebase in the market, that's why we are hosting these learning series, this particular cloud event, because both Shivank and I are men on a mission, and we basically want to increase the awareness for Flutter and Firebase. And Lauren has been kind enough to help us out on our journey.
Amazing. All right, it looks like there might have been a clarification around the previous question of using cloud functions to support the Dart language. So is there any additional clarification or context given it's more about the Firebase side, so writing functions in Dart?
So I think to answer that question, Jin, that is I think already on the pipeline for the Firebase team, and that should be out soon. But to be able to comment on a timeline wouldn't be possible right now because myself and Utkarsh would not have that visibility. So I would just suggest that for now sit tight, and that should be out soon.
Yeah, and in the meantime, you can use the resource that we provided earlier in the chat.
Great. Okay, keep the questions coming if you have them. I know we just have a couple minutes left, so I think we can cover just a few of the remaining pre-submitted questions. So if you don't mind going to the next one, I think we can get through these before the end of the hour.
Sure.
So the next question is, how do you best integrate machine learning engines like Onyx Runtime or TensorFlow Lite with own trained deep neural network models?
Shivang, do you want to take this or?
Yeah, sure. I can take this. So that's a good question, and to answer that, it would be a very long answer. So bear with me on that. So for integrating the ML engines, there's a long journey that you have to follow. So starting with the conversion of the trained model. So first of all, you would need to convert your trained DNN to the deep neural net model to a format that is compatible with Firebase MLKit. So recently and like mostly TensorFlow Lite is a very commonly used format supported by Firebase MLKit, and you can follow the TensorFlow Lite model conversion process for converting your own model, and this way your model would be included in your Flutter application. So once you have done that, the next step would be to add this converted TensorFlow Lite model to your Flutter apps assets directory. and to ensure that it is included in the obfusc.yaml file as an asset. That would be the second step that is required. The third step would be setting up a Firebase. So, to ensure that you set up Firebase in your Flutter project and enable the necessary Firebase services, including the Firebase ML kit. And you could also refer to the great Firebase documentation that is out there for detailed instructions on how to add Firebase to your Flutter app. Once you're able to do that, the next steps would be to integrate the Firebase ML kit within the Flutter. So for that, you would need to use the Firebase ML kit Flutter plugin, which would be used to increase and to leverage the ML capabilities. And once all of that is done, your project would be all set up. And to go further, you would need to pre-process the input data, which is as required by your trained model. And once you're done with that, you can use the plugin again to pass the pre-processed input data to the TensorFlow Lite model and then run inference on that. So this way, you can retrieve the output predictions from the Firebase ML kit and process them as needed in your Flutter application. And you can utilize the additional Firebase ML kit features again, which could be like exploring the image labeling, the text recognition, the object detection, and more. So you can also follow the documentation and the examples provided by the plugin, which could be used to incorporate the features into your Flutter application. So I hope that gives some idea, and I hope that can help you in this journey. Thanks.
Fantastic. Thank you so much for answering these questions, for the demo, the information that you shared today, and thank you everyone for joining us. We are at the hour, so I want to be respectful of everyone's time. But if you do have a moment, we'd love to hear from you in the feedback form about what you liked, what you'd like to see differently, or topics that we can cover for future sessions. So please, we'd love if you could take the time to do that. But before closing out, Utkar, Shivang, thank you so much again. Do you have any final thoughts or recommendations before we close out today?
Uh, so first of all, I mean, I want to thank you for all your efforts in setting this up. Both of us really appreciate it. And secondly, thank you so much to our audience for joining this and, taking time out of their busy schedule to join this and, taking part into this conversation, asking some questions. So it was an amazing experience. And thirdly, I would strongly recommend, to go through the learning series that Shivank and I have created. So it will give you a very good idea about Flutter, Firebase, plus along with the articles that we have written, all those blogs also have a YouTube video embedded into it as well, which you can use to follow along and practice on your own time as well. So please feel free to take a look, and if you have any questions for regarding those articles, please feel free to drop a question in the comment section of those articles. So thank you
Thanks,
so much.
Utkarsh. Just to add to what Utkarsh said, thanks again, Utkarsh and Lauren for this wonderful event, for hosting this, for organizing it. Thanks to all the audience for taking part in it and to join in from your busy schedules. And apart from this learning series, we also have a book available on Amazon and Google Play Store as well, Playbook as well, where you can read more about Flutter and Firebase. So do check that out too. Thank you, everyone.
So
Fantastic.
shamelessly, I have pasted the link to that book on the private chat. Lauren, could you please do the honors and post it in the public section? So if our audiences do want, they can go ahead and check that book out.
Absolutely. Dropping it in now. Thank
Thank you.
you all so much for your time, and we hope to see you at the next one.
Thank you,
Thank you.
everyone. Bye
Have a
bye.
good day. Bye.